Welcome to our third session of our learning today, and we want to introduce something about reversible reactions. This is the second part of this question of this topic. So we have what we call reversible reactions, or we call it chemical equilibrium. Chemical equilibrium. So in this part, we shall look at different types of reactions, different types of reversible reactions, then look at the chemical equilibrium, the equilibrium reactions. So just to start with, equilibrium is a state of balance. When a chemical is said to be in equilibrium, if it is in state of balance, if it is in the state of balance between the reactants and the products. As reactants form products, some products form back the reactants. So in such a situation, we call the equation is in equilibrium. The reactants are forming the products as products form the reactants. So reactions in which the reactants form products to completion are said to be irreversible reactions. They cannot be reversed back. So the reactants are forming the product to completion. You have the reactants, then they react completely to form the products. So you have an example of an irreversible reaction here. A reactant A reacting with B to give the products C and D. So such reaction, we call it irreversible reactions. Then reactions in which the reactants form products and the products can reform the reactants are said reversible reactions. They can be reversed back. The reactants can form the products and the products can also form the reactants. So an example is here, A plus B to give this is a sign of irreversible reaction to give C and D as the products. So a reversible reaction may be one, it may be a physical change. One may be a physical change. It can be a chemical change or equilibrium. So we shall look at reversible physical changes, look at reversible chemical changes, then look at dynamic equilibrium, the reactions that are at equilibrium. Let's start with the reversible physical changes. So from this, we know there are types of reactions. We start with two types of reactions. There are those reactions that can be reversed and those reactions that cannot be reversed. Just like in our daily life, the activities we do, there are those that can be reversed and there are those that cannot be reversed. So can you name some of the examples of activities you do that can be reversed and those that cannot be reversed? Okay, good. Okay, that's good. So there are so many activities we do in our daily life. Some can be reversed while some cannot. Like an example is like while somebody melting solid cooking oil. When you melt solid cooking oil, it changes to liquid. So you say the reactant is this solid cooking oil. Then it has changed to the oil to a liquid. So liquid is our product. So if that liquid stays for some time and cools, it changes back to a solid. So we say that type of change is what we call reversible change. So it has changed from solid to liquid, then from liquid back to solid. But there are some other activities that cannot be changed. Like somebody, let's say like somebody frying chips. So uncooked chips are white in color, but after they have been cooked, they become golden brown. So they have changed the color. That's a change from whitish to golden brown. So such a process cannot be reversed. There is no way that you can change the golden brown chips to the whitish, or the cooked one from uncooked one. So such an example is an activity that cannot be changed. So the same thing happens to chemical reactions. There are some that can be reversed and some that are not reversed. So we have said those reactions that in which the reactants form products to completion are said to be reversible. The one that cannot be reversed. But the one in which the reactants form products and the products can reform the reactants are said to be irreversible. They are said to be irreversible. They can be changed they can be reversed back. So we will start by looking at reversible physical changes. Reversible physical changes. So reversible physical changes is one in which involves one change of state, or we can call it change of phase. So that is change from solid to liquid, or to gas, or in aqueous solution. So it can change from solid to liquid, liquid to solid, liquid to gas, liquid to aqueous solution, solid to any those physical state, or the phases. Then so states of matter are in convertible, and a reaction involving a change from state can be reversed back to original. That is now in reversible physical change. Then two, color changes. So some substances or compounds change their colors without change in chemical substance. So they can change from black to white, from white to yellow, from yellow to brown. We call it, that's a physical change. So when we're looking at reversible physical change, we'll be looking at physical changes in two ways: the change in state or the change in color. The change in state or the change in color. So we shall look at some examples of reversible physical changes. Examples of reversible physical changes. So we'll start with color change on heating and cooling. When you heat a substance and cool a substance, there's some chemical substances that undergo physical change. So remember, if we're talking about physical change, we're talking about change in color or change in state. So the first one, the color change on heating and cooling, where we use zinc 2 oxide. When zinc 2 oxide is heated, it changes from white, and when it's cooled, it changes to yellow. So zinc 2 oxide is white in color, we know that, and hot zinc 2 oxide is yellow in color. So it will be white. After heating, it changes to yellow. Then when you cool, it becomes white again. So we call it reversible physical change. The change of color from white to yellow, then from yellow back to white. So that's the first type of irreversible change. Then there is lead 2. lead 2 oxide. What's the color of lead 2 oxide when cold? Good. So it is white. It is yellow when cold. What about when hot? Good, it's brown. So lead 2 oxide changes the color from yellow to brown while heating, and when it's cooled, it changes from brown back to yellow. We call it reversible physical change. Reversible physical change. Then another change can occur through sublimation. So we know this chemical substance, an element called iodine. We handled iodine the first time when we were in Form 1, when we were looking at separation of substances. So we say that an iodine sublimes, it sublimes. An iodine sublimes. So when it's heated, it changes directly from solid to a gas, the vapors. So we are saying it has changed its physical state. When you heat solid iodine, it changes directly from that solid to a liquid. So there are two types of changes there. One, it has changed its physical state. Imetoka solid ikakuwa vapor, and when the vapors are cooled, they change back to a solid. So imetoka solid ikaenda ikakuwa vapor, then from vapor then ikarudi ikakuwa solid. Then also another change is the change in color. When it's in solid nature, it's gray, or when it's either solid or powdery, it's gray in color. That is iodine. But when you heat it, it changes to vapor. Then also the color changes. So the color of iodine vapor is purple. So it has changed from a gray solid to a purple vapor. So I'm saying there are two changes there, from solid to vapor, then the color from gray to purple. Also, we talked of carbon 4 oxide on the same sublimation. You remember some applications of sublimation. This carbon 4 oxide, also called the solid carbon 4 oxide, is also called the dry ice. It's used by ice cream vendors in the ice cream boxes. So this carbon 4 oxide, when it's heated, if it's heated, the solid, I'm talking of the solid carbon 4 oxide, when it's heated, it changes to vapors, the colorless vapor, the gas itself. And when these gases are cooled at a certain pressure, at a very high pressure, it should be high pressure, it changes back to a solid. So those are also two changes. It's in solid state. When it's heated, it becomes a gas. So from solid state to gaseous state. Then the color also changes. Solid carbon 4 oxide is white in color. It's white in color. When it's solid or in powder form, it's white in color. When it's heated, it becomes a colorless gas. Then the colorless gas can also be reversed back to a solid, that is white. So you are condensing, you are cooling a colorless gas, then it forms a what? It calls deposition. You are depositing a colorless gas that is a colorless gas, then it becomes a white solid once it forms a solid. So those are also two types of changes. Then another type of physical reversible reaction is melting and freezing. Melting We made the melting, freezing, and boiling and condensation. So melting, freezing, we know it melts, then freezes. Then boiling, it boils, then condenses. So we call it an example. The first example is ice. What is ice? Ice is just water in solid form. So ice is water in solid form. So when this water is heated, it undergoes change. So we say it melts into a liquid. So it has changed from solid to liquid. It's called melting. Then when the liquid freezes, is put under low temperatures, it becomes a solid again. So from liquid to ice, from liquid to ice. So that's a reversible change. Then the same water in liquid state, when it's boiled, it becomes water vapors. And when it's condensed back, when it's cooled, it condenses back to a liquid. That's a type of reversible physical change: melting, freezing, and boiling, condensation. The other one is dissolving or crystallization, or what you call distillation. So there's if you have a solid crystal of a solid substance, those are the solutes. When they dissolve in water, they form a uniform mixture of a solute. And a solvent solution. We call it a solute solvent or a solution. On crystallization or distillation, or you can call it on evaporation, the solvent evaporates, leaving the solute back, e.g. in sodium chloride. That's also a type of reversible reaction. You have a solute, you have a solvent. When you mix the two, they form a uniform solution. That's another substance different from the first one. This is a solution. It was a solid. Then you mixed with a solvent, it became a solution. So they have changed their physical state. It was a solid and a liquid. Then after mixing, they become a solution. Then if this solution is crystallized, or we call it, if it's evaporated, the solvent leaves, then it leaves the solute behind. So you get back your crystal. We call it a reversible change. It can be reversed back to the products can be reversed to form the reactants. So those are examples of physical reversible changes. So tomorrow we shall look at reversible chemical changes and also dynamic reversible changes. Goodbye.